So we've learned about how to write conclusions, what kind of mistakes we can make when we make decisions, actually, which we will make when we make decisions, namely the type 1 and type 2 errors, and we've learned how to set up hypotheses. It's time for us to kind of put it all together. But as you put it all together, and as we keep doing this over and over and over and over and over again for the next several chapters, right, we want to keep in mind a couple things, namely this exploratory example. So what means statistically significant? It means that we're going to reject the null hypothesis. That's what we're looking for. We're looking for the statistics of what we're doing to be significant enough that it supports the alternative hypothesis. All right? Okay, so there's two ways that we can prove that things are statistically significant, i.e. reject the null hypothesis. We can use the classical method or the p-value method. All right, now the classical method, remember Steve's die. Steve had 12 out of 12 fives, way back here, right? So we knew Steve's was rigged. Well, we don't know it, but we know it's highly likely. Now, how do we know it? And the answer is, well, there's two ways you can think about this. You can think, okay, his data was so far away from the rest of the group. As a matter of fact, his z-score, which I wrote it up here, but I didn't bring it down there, but I will now. Hold on. 12 out of 12 is far away from the rest. Matter of fact, I'm going to grab both of these. 12 out of 12 is far away from what we expect. It's a z-score of 7.75 for the love of goodness. Okay, that is really huge, really unusual. Well past the two unusual that we talked about in chapters 3 and beyond, right? Okay, so oops, there we go. All right, so that's one way you can spot it. You can say, hey, look at his z-score. His z-score is so far out there that it's unusual, right? And we reject that the die was fair. That's the classical approach. The p-value approach is saying, look at the probability, look at the chances of getting what he got by accident, by random chance, right? That is the p-value, the probability. Now, we learned how to find that before. It's binom dist. And it's so low that you know something is up with it. You know something is up with his die. Okay? We're going to use the p-value approach more because that's what computers use, but we're going to do both of them because both of them can show up on the final exam. So we're going to show both ways. We're going to show it all the time. All right, now this is the first page of your inferential statistics cheat sheet. And again, I recommend you have that on you at all times. Do not set it down. Don't put it anywhere. Keep it right by your computer, by your books, by your whatever. You are going to have this given to you on the exam, on the final exam, and on your third exam if you're a face-to-face student. So you're going to have this with you. And if you're taking an online class, you should have it with you for all your quizzes, all your tests, everything. Okay. Now you can see steps 1, 2, 3, they're the same. Step 4 and 5 are different with the classical approach, which is honestly the harder one, or the p-value approach. Okay. We're going to do both. We're going to do it all. And then step 6 is when we state the conclusion, which is the same for both of them. All right. Let's go back to our panel of juries, shall we? So if you recall, this was the Southern States African American jury panel. Should have been 50% because 50% of the people in the county, for example, were African American. But on an 80-person panel, only 5% were African American. That's problematic. All right, so we want to test the hypotheses that the jury was rigged using the classical method here. So this one says classical, so we're going to stick with it. All right, step 1, we need to make hypotheses. Now, we assume that the proportion of African Americans on that panel was 50%, like it should have been, because 50% of eligible citizens were African American. We assume that to be true unless we can prove it otherwise. Okay, so and then the alternative is the rigged part. Well, if it's going to be rigged against these African American defendants, then it would be lower than 0.5, significantly lower, less than. Now, alpha. Alpha is our level of significance. And if you notice, this is one of the rare cases where I did not give you one. So we just have to make a decision on our own. But remember, this is the chances of, letting an innocent person get convicted or a guilty person walk free. Neither one of these are good things. So we're going to set our alpha as a pretty low bar. which is a good thing, right? So, for example, down here, you can see these are really far away from this. This is really far away from the mean. This is really low. We are going to set our threshold for whether or not we're making a mistake here to be really low, 0.001. Very small, even less than the 5%, which we've traditionally used as our unusual threshold. We're going to lower that, even lower than 5%, and make it 0.001. I can make it lots of other things too. I can make it 0.006 or 0.004 or zero point 0.2 or, whatever. But since I don't want the chance of making a mistake to be high, I'm going to make it pretty small. Okay. So then I need to find the test statistic. So that's z0 equals p hat minus p0 over the square root of p0 times 1 minus p0 over n. Okay. Now, what are all these numbers? Well, let's think. So p hat is 0.05. That's the sample proportion that actually showed up. Oops, let me make this bigger so you can see it. Oops, there we go. All right, p0. Now, does the 0 look familiar right here? It sounds like h0, right? Right. It's what you assume to be true in that null hypothesis, that h0. That's what you assume to be true of that proportion. So we assumed that it was 0.5. So you put 0.5, 0.5, 1 minus 0.5. Everywhere there's a p0, you put what you had in your null hypothesis, 0.5. Okay. And then n is 80 because it was an 80-person panel. All right. Now, I could just find this way with, a calculator. That's cool. You've got a calculator, you can do it. You can also use Excel or StatCrunch or whatever to do this for you. Honestly, I would probably use Excel, StatCrunch, which gets to one of my other points I was going to make, and I can make it now. We are almost never going to use Excel from here on to the end of the course. We're going to use StatCrunch, and we're going to use it a lot. And you'll see why in a minute, but it's because it's a lot easier for this stuff to use StatCrunch than Excel. So one thing I want to make a note of real quick, p hat, which is our sample proportion, we learned a formula for p hat back in section 8.2. It's x over n. Now notice they told us that this was 0.05, which means that it's x over 80, right? So if you want to solve this for x, you just times both sides by 80, and you'll have it. There we go. So times it by 80. Oops. And then times it by 80 over on the other side as well. There we go. And you're going to get 4 is equal to x. So just keep that in mind for later reference because we're going to need that. All right. Next, we need the critical value. Now, we can get this from our table, or we can get it from Excel or even StatCrunch. We can get it from a lot of places. But we're going to need the critical value, which if you look here, we're doing the left-tailed test. So let me scroll in. We're doing this one right here. So that critical region, that's your alpha right there. So we need alpha and we need z alpha, which we learned how to find, negative z alpha, which we learned how to find back in section 7.2, or yeah, 7.2. Okay, so I've found it already. It's negative 3.09, but let's find it with technology. So this was just some random example, and I'm going to need a blank sheet in here. So this was random die rolls, right? Just proving we know how to use that random function. And then in here, we've got, this is section 10.2, number 1, so example 1. So 10.2, example 1. All right, now how do we find that critical value? Remember that alpha was equal to 0.001, right? Really small, we made it. Okay, so then z alpha, actually we want negative z alpha because we want it to be on the left. That's equal to, oh, it's not going to like me. Hold on. I'm going to have to change that. You know what? Here's what I'll do. I'm just going to call it z alpha. Actually, I'll call it critical value. How about that? Crit value. Okay, so this is equal to norm dot inverse, right? probability is 0.001, comma 0, comma 1. There we go. Done. So that's how to do it with Excel. If you want StatCrunch to do it instead, because you like StatCrunch, hold on. Oops, let me shut these windows. You don't need that. It's election day, so I was looking for polling data that I could use for you guys. So, all right, so let's see here. We want, we want calculators. We want the normal calculator, and we want to tell it 0, standard deviation 1, that's fine. I want the probability of this to be 0.001. Compute. And there it found it, negative 3.09. It's right there. So if you wanted to use StatCrunch, that's fine. You can copy and paste it in, or you can use Excel. Either way, make a picture and find it. So 10.2, example 1, step 3, export. I have to go to my results. Oops, hold on one second. My results, there we go. Copy. And I'm going to bring it back here and paste. All right, there. So we got it with Excel, we got it with StatCrunch, life is grand, we got our critical value. Do it either way. I don't really care which way you do it, just as long as you do it one way or the other. Okay. Oh, and don't forget that you can do it from a table. Hold on. Let me go find that. That's under Tools for Success. Oops, let me reload. There it is. All right, Tools for Success, Formula Table card. And we wait while it loads. Make sure you have the most recent Java to do this. And there it is. Okay, so we picked, it's in the bottom row of the t-table. So if you take the t-table, go to 0.001 and slip to the bottom, which is the Z column. You can see Z. It's 3.09. And of course, since it's left-tailed, it's got to be negative 3.09. So you can get it from the table, like say you're on the final exam, you could get it from the table. If you're working on a computer, you could use StatCrunch, you can use Excel, you can use whatever. One way or another, you've got to come up with that Z alpha is negative 3.09 if you're going to do the classical method. Okay, so then I've got it drawn a picture, right? They drew it in step 4, so you have to draw it by hand. So you draw a little picture. You want to draw the left-tailed picture because that's the one you're working with. So you draw whichever one is the one you're working with. So I drew a left-tailed picture. I've got 3.09 put right there, and then you can't see it, but it's shaded just a little bit over there because that's 0.001. So I drew a picture, shaded it, found the critical value. Find it by the table, find it with Excel, find it with StatCrunch, just find it. All right. Now, we are going to be rejecting the null hypothesis. According to this thing right here, the left-tailed test, if Z0, which is what we found up here, which was negative 8.05, is less than that negative Z alpha critical value of 3.05, we will reject the null hypothesis, which in this case we will. So we're going to write, I reject the null hypothesis because that Z0, which is negative 8.05, is less than negative 3.09. Another way you can say that is it's Z0, hold on, is in the critical region, right? So we said anything past 3.09 is in our critical region. So if you get a number past that, it's going to be rejection of the null hypothesis. So we were saying, hey, we'll take up to 3 standard deviations away, 3.09 standard deviations away, but anything past that is too suspicious. And we are well past that. 8.05 is 8 standard deviations away. It is a long ways away. Standard errors, technically, but whatever. It's still a really long ways away. So we're going to reject the null hypothesis. And since we reject the null hypothesis, we write our little statement up. There is enough evidence to support the claim that the jury was rigged, i.e. that the proportion of African Americans was too low on that jury panel. By the way, this is a compilation from some real cases that I found in the Cartoon Guide to Statistics, and this was real stuff. These were not just made up. This actually came from some real trials of African American defendants. All right, we'll pick back up here for the p-value next time, but we've seen the classical method, at least how it starts and finishes, I suppose.